a free end in this case, the end of the column is neither fixed in position nor in direction. Means if a column is like this, let us say draw a like this, a column will be like this. See, if any force acts in this direction, it will just sway. Means not only it, for example, not only in the position, it is the initial position. So this is deflection and this is rotation. Means in both position and direction it will change. In both position and direction it will change. Okay, so that is for now. Let us discuss classification of columns. Very important topic regarding these competitive examinations: long columns, short columns, and medium or intermediate columns. What is a long column? Yes, very important. A long column is column which fails primarily due to bending stress. Primarily due to bending stress. A long column is which fails primarily due to bending stress. Because in long columns, direct stresses are very small compared to their buckling stresses. That means long column will fail only or mainly due to buckling phenomenon. That means if a column is like this, if a column is like this, so if the length of the if the height of the column is a very large when compared to its other dimensions, then the column will not simply start buckling, like buckling phenomenon. This is buckling phenomenon. Means irrespective of load, buckling phenomena is irrespective of load. Buckling phenomena is irrespective of load. Buckling phenomena is irrespective of applied load. It is primarily due to its dimensions, because of column, height of a column. Okay, but not at all due to direct stress. Not at all due to direct stress. It fails before itself. For example, it can, for example, a column is there, it can withstand some load. Means it is applied direct load. For example, say this column and this column both are having some wait a minute, applied loads. This can withstand more load than this because this long column will fail before the impact of direct stress. Before the impact of direct stress means it will fail by itself because of buckling phenomena. Okay, okay. Now we'll discuss. Long column is a column whose slenderness ratio is greater than 120 or whose length is more than 30 times the least lateral dimensions. That is, length greater than 30. The length of a column or height of a column is greater than 30 times the breadth or some least lateral dimension, then that column can be classified as long column. Or the slenderness ratio, if the slenderness ratio is greater than 120, then also it will fail. Then also it will behave as a long column. Then also it will behave as a long column. Okay. What is slenderness ratio? What is slenderness ratio? Very, very, very important. What is slenderness ratio? By the name itself, slender means something related to length. Slender means something related to length. I will write here. Slender means related to height or length. Slenderness ratio. Slenderness ratio. Slenderness ratio. Okay. It is a ratio of effective length. It is a ratio of effective length to least radius of gyration. Least radius of gyration. We will denote radius of gyration by slenderness ratio is defined as a ratio of effective length to the least radius of gyration. Okay, so this is what slenderness ratio. And if the slenderness ratio is greater than 120, then the column can be classified as long column. And for mild steel columns, the slenderness ratio is greater than 80. Okay, it's greater than 80. So here I have to discuss what is radius of gyration. What is radius of gyration? I will write here. Just a second. Radius of gyration. Radius of gyration. What is radius of gyration? Okay. So what is radius of gyration? The radius of gyration, very important topic. Radius of gyration. Radius of gyration. Radius of gyration is nothing but a ratio of moment of inertia I to cross sectional area, okay, under root, defined as ratio of moment of inertia to the cross sectional area, moment of inertia to cross sectional area, and it is denoted by k. Radius of gyration is denoted by k. And what is the unit of k? It has no unit, because the unit of I is mm power 4, the unit of area is mm square, so we'll get mm square, under root will get mm. So sorry, the radius of gyration, the unit for radius of gyration is mm. Okay, so radius of gyration will be always denoted in mm. Very important. Okay, if you square it, k square is equal to I by a, and I is equal to a into k square. So this is commonly used relation. So the relation between I, moment of inertia, and area of cross section and radius of gyration is I is equal to a k square, whereas k is radius of gyration, and it is defined as a ratio of moment of inertia to the area of cross section under root. Okay. Now, what is slenderness ratio? Slenderness ratio is the ratio of effective length to the minimum radius of gyration. Effective length to the minimum radius of gyration. Okay. Now, now, yes, we have here. Yes. Wait a second. Yeah. Now see the what is the ratio? I mean, what is the value of slenderness ratio for short column? If slenderness ratio is than 32. Here it is less than. Okay, if slenderness ratio is less than 32, slenderness ratio is less than 32, or whose length is less than 8 times reach lateral dimensions. If L is less than 8b, if L is less than 8b, or if slenderness ratio is less than 32, then it is called short column. If it is more than 120, long column. If it is less than 32, short column. But for a mild steel column, it is just 80. Greater than 80, long column. Less than 80, short column. Okay, for mild steel columns. And if the value lies in between them, then it is called medium or intermediate columns. Medium or intermediate columns. Okay. Now we are going to the next topic, that is effective length of a column. Sorry with this technical timeout. It's taking some time to load this printout. Okay, so meanwhile we'll discuss the theory part of this effective length of a column. Okay, so what is effective length of a column? So now we are discussing about the here we have sorry. Okay, effective length of a column. Effective length of a column. What is effective length of a column? Yes, the effective length of a given column with given end conditions is the length of an equivalent column of the same material and cross section with hinged ends having the value of a crippling load equal to that of given column. I will repeat once again. The effective length of a given column with given end conditions is the length of an equivalent column with hinged ends. Okay, means always means, yeah, here a column is always compared to a standard column, always compared to a standard column of a standard column having both ends hinged. both ends hinged. Okay, see here, the effective length of a given column with given end conditions is the length of an equivalent column. Sorry, yeah, is the length of an equivalent column of the same material and cross section with hinged ends. This is very important, having the value of crippling load equal to that of given column. Very simple, very simple. Now I will show you the uh, in a pictorial representation. For that I will just change the color. Yes, wait a second. Just wait a second, where is my cursor? Yeah, for example, this column is there. It is having both ends hinged. both ends hinged, and it is having some load, having some load, and it is always compared to a column, a column which is having hinged end, and same load P. If it is P, it is also P. So this is how column is compared. So I'll write here as standard column. I'm sorry, this is given column. This is given column. This is standard column. Always a given column is compared to a standard column. What is a standard column? A standard column is a column having both ends hinged. Okay, both ends hinged. That's why, that is the reason why, that is the reason why always, very important, always effective length of a column, both ends hinged, effective length of a column having both ends hinged. So effective length is always equal to L. But for a column having both ends fixed, effective length will be L by 2. L by 2. Okay. It is having L by 2, means half of the length of the standard column. Now, if a column is having one end fixed, other free, then effective length is 2L. Very 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 important, because of free support, free end, and having one end fixed and other hinge, then effective length is equal to L by root 2. L by root 2. Very 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 important. So these are the effective lengths of different columns having different end supports. So very very important in almost all examinations. Okay, clear? Now one important point, that is let me show you here. Yeah, here my cursor is here. Yes, yes. Yeah, effective length of a column mainly depends upon end conditions. Effective length of a column mainly depends upon end conditions. Okay, effective length, effective length of a column mainly depends upon end conditions. Okay, so then what is actual length? Actual length is not that much vital in this topic, but we'll discuss what is actual length. Actual length, the of a column is the distance between the center to center of effective lateral restraints. Just know the definition. There is no particular formula or like this any. I mean, there is no some exact definition. Okay, actual length. The actual length of column is the distance between center to center of the effective lateral restraints. Just remember like that. Effective lateral restraint. It is nothing but actual length of a column. Okay, sure. Now that's it. So radius of gyration we all discussed, it is the ratio square root of moment of inertia to the cross section area. It is known as radius of gyration. We all learned it. I, A, K, and what is Slenderness ratio? Yeah, yeah. Just now we revised this thing. The ratio of effective length of least radius to gyration is called as slenderness ratio. It is L by K minimum. Yeah, and yeah, very important. The load carrying capacity of a column, especially The load carrying capacity of a long column depends upon slenderness ratio. The load carrying capacity of long columns depends upon slenderness ratio. If the slenderness ratio is more and more and more, then the long column will not carry more loads, because it will easily buckle. It will easily buckle. That means slenderness ratio is directly proportional to buckling. The height of column is more, then the ratio, I mean the slenderness ratio is more, then buckling will be more. So that's why the load carrying capacity of long columns depends upon slenderness ratio. Very, very important. See how this type of questions are asked. So a question will be asked like that. For example, the question will be: the load carrying capacity of a long column depends upon number one, slenderness ratio; number two, direct stress; number three, bending stress; number four, its dimensions or applied load, like that. So you are given with four options. You have to select one option like that. Option E, both option A and option B are correct. Option 4 is correct, or option 1, 2, 3 is correct, like that. Okay. So, but remember this, always remember this: the load carrying capacity of long column depends on slenderness ratio. Of course, it also depends upon buckling stresses, means bending stresses. Okay. So the main criteria here, the what you call the key role is being played here by this slenderness ratio, particularly in long columns. Okay. Yeah, see here, very, very, very important. The for good design the slenderness ratio is as small as possible. Very, very, very important. For good design the slenderness ratio is as small as possible. Very, 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 very important. That's why I told you earlier, if the length of a column more, then slenderness ratio will be more, then the column will not bear much load, it will bear less load. Okay. If slenderness ratio is a less, then column will bear very high loads. Okay. Now, what is safe load or what is working load? Okay. This we'll discuss in the next class.